During your next pre-calculus class, you're going to have your first semester CCA. And I've made a practice that's really, really, really similar to the CCA that you're going to take in class. So I suggest you pay attention. Now let's say you're given f of x equals 3 of x. And your first task is to find the inverse of f of x. Well, we know a few things. First of all, we know that if we need to find the inverse, we can, instead of writing f of x equals 3 to the x, we can write y equals 3 to the x. Then if we need to find the inverse, we're going to switch the x and the y. So instead of saying y equals 3 to the x, we'll say x equals 3 to the y. Now if 3 to the y, we can write that as 3 to the y equals x, instead of x equals 3 to the y. Then we know that if we convert that to logarithms, we know that we have log base 3 of x equals y. We can rewrite that as y equals log base 3 of x. And we know another thing. We know that the exponential and logarithmic functions are inverses of one another, so this should make sense. That if f of x equals 3 to the x, the inverse of x equals log base 3 of x. Now, the next thing that we need to do is explain how to verify this algebraically. Well, I'm sorry, verify algebraically that these functions are inverses. Not only show it algebraically, but be able to explain how to verify algebraically. So the next task that you'll be given is to explain how to verify algebraically that these functions are inverses. So what you're going to do is you're going to make the original function f of x and make the inverse g of x. Now remember, if you take two functions, f of x and g of x, and you want to verify that they're inverses, you say f composition g of x has to equal g composition f of x, and both of them have to simplify to x. So if the left side of the equation equals the right side of the equation and they both equal x, two are inverses. So let's verify it algebraically. If f of x is 3 to the x and g of x is log base 3 of x, and we want f composition g of x, we just say 3 to the log base 3 of x. And then we set that equal to g composition f of x, which would be log base 3 of 3 to the x. Now if you know your log rules, you can check them out. If you have 3 to the log base 3 of x, that means that you simply have, that simplifies to x. If you have log base 3 of 3 to the x, that also simplifies to x. Check out your log sheets, your log rule sheets, and that should be readily apparent. That proves that they are inverses of one another. The next task that you would be given is to graph f of x, which was 3 to the x, to graph the inverse of that, which is log base 3 of x, and then graph y equals x. Now, the key here is to remember the critical points for an exponential function and to remember the critical points for a logarithmic function. The critical points for an exponential function are 0, 1, 1 comma a, and negative 1 comma 1 over a. In this case, a is 3 because we have y equals 3 to the x. It's y, the general case is y equals a to the x. So we simply put in 3 wherever we have a in the critical points. So we have 0, 1, which is right there, over 0, up 1. We have 1, 3, which is over 1, up 3. And we have negative 1, 1/3, which is back 1 and up a little bit. And then we make the graph based on those three critical points, knowing that there's a horizontal asymptote at y equals 0. Now, and that's, again, y equals 3 to the x is in red. The critical points for a logarithmic function are the inverse of those points. Instead of 1, 0, you get 0, 1. Instead of 1a, you get a1. Instead of negative 1, 1 over a, you get 1 over a, negative 1. And because a equals 3, we have log base 3 to the x. The general case is log base a to the x. So you have these critical points, 1, 0, which is right here, over 1, up 0. You have 3, 1, over 3, up 1. And you have 1/3, negative 1, which is over just a little bit and then down 1. And that is, I finished drawing it with the blue graphical representation. And you can see that they are inverses of one another because they are reflected across the line y equals x. And I didn't write it, but please note that there is a vertical asymptote at x equals 0 for the logarithmic function. So the next thing you'll have to do is explain how you can tell that these functions are inverses just by looking at the graph, and you can tell that they're inverses because the graph of one is the other reflected across the line y equals x. Y equals 3 to the x in red, y equals log base 3 of x in blue, y equals x is a straight line that passes through the origin and has a slope of 1, and one graph is the other reflected across the the line y equals x. If you could do that, let's say hypothetically, instead of your starting equation f of x equals 3 to the x, it might be f of x equals some other number to x, and then you'd have to do all the same things. Hint, hint, wink, wink, nudge, nudge.